Hey guys, welcome to the next video on OpenCV tutorial for beginners using Python. In the last videos, we have learned some important concepts in OpenCV. Now in this video and the next few coming videos, I'm going to create a simple project which uses most of these concepts which we have learned in the previous videos. So what we are going to do is we are going to create a very simple lane detection system. So first of all, we will start with a still image. You can see there is an image which contains this road, and this road contains lanes. So what we want to achieve is we want to detect these lanes on which our vehicle is traveling. So first of all, we will do this with this image, and gradually we will move towards the video frames. So first of all, we will see how to detect these lanes in this image, and then we will see how to detect these lanes in the moving video. So let's get started. So I have created this new project in my PyCharm IDE. You can use any other editor of your choice, and first of all, obviously you just need to install OpenCV Python package and Matplotlib package. Once you have done that, I will create a new file here. So I'm going to just right click here and create a new file, and I'm going to name this file as detector.py file. So here we are going to import a few packages, for example Matplotlib. So Matplotlib .pyplot as plt. So let's say as plt. Also we are going to import the cv2 package, and we are going to import numpy. So import numpy as np. In the next section, what we are going to do is we are going to simply load an image. So I'm going to create an image variable. So image is equal to cv2.imRead, and we are going to read our image, which is the road image. So road.jpg. Now in the next line, we are going to convert this image into the RGB format, because we are going to load this image using Matplotlib. So I'm going to just write once again image. So I'm going to overwrite this image variable with the converted image. So cv2.cvt color, and the source is our image. So this is the variable, and then cv2.color from BGR to RGB, right? So this is what we want to use. Now in the next line, what we want to do is we want to load our image using plt.imshow method, and at last we are going to just say plt.show. So this is how we are going to just load our image. So I'm going to right click on this file and then run this script, and you can see this road.jpg image is loaded. Now on this plot, you also see these values, and one thing to observe here is horizontally these values goes from 0 to 1200 something, and vertically normally in the graphs you will see that values increases from the bottom to top, but in Matplotlib this value goes from top to bottom, right? So 0 is at the top, and then the maximum value will be at the bottom. So this is one thing to note, because we are going to define our region of interest, and that will be based upon these values. Now in the next step, we want to define our region of interest. So once again, let me just run this code once again. And one thing to notice here is this lane in which our vehicle is traveling is parallel. So there are two parallel lines, and eventually they are going to merge here, right? So all the lanes on which the vehicle travels have the same pattern. So this lane and this lane are parallel to each other and they are going to merge at some point. So it's not merging, but it seems to be merging at some point. So we can define our region of interest from this point to this point and from this point to this point. So this region of interest will be the triangle. So this region of interest we are going to define for our vehicle will mask any other obstruction. For example, this is also one lane line. For us, it's not important because this is the other side of the lane. So here the vehicle will come in the opposite direction. So this is our region of interest. So it will mask out this lane line or any other lines or distortions which we have in this picture. We are going to just mask them and we are going to just concentrate on this triangle. So let's do this first. So first of all, we are going to find out the shape of the image. So I'm going to just print, and then we are going to just say image dot shape, and also we are going to just define the height and width of the image. So I'm going to just say okay. So let's print this value and let's see what happens. So what's at 0 and what's at 1. So you can see it prints 704 as our height and 1279 as the width. So this is what I am just taking from this image shape method. So it's going to return this kind of tuple. So at 0th index there will be height, and at the first index there will be the width. And as I said, it starts from 0 to 704 from top to bottom, and horizontally it goes from 0 to 1279 from the left hand side to the right hand side, right? So once we have the width and height, we can define our region of interest. So we are going to define a variable called region of interest vertices, and here we are going to provide some values. So we are going to provide 3 points which will be the 3 points of our region of interest. So as I said that our region of interest we want is this point, which is the left bottom corner, this point which is the right bottom corner, and somewhere in the middle of this image. So here, so in the image, because the vertical height starts from 0, so I'm going to just say 0 comma height, and the second point will be the half of the width and half of the height, which will be the center of the image. So I'm going to just say width divided by 2 comma height divided by 2, and this will be inside these parentheses, and the third point will be the next corner. So this will be width and then the height. So let's try to see these points in our Matplotlib window. So the first point here is 0 comma 704, which is this point. The second point is somewhere here, which is the half of the height and half of the width, and the third point will be here, which is width comma height, which is 700 comma 1279, which is this one, right? So this will be our region of interest. Now we are going to define one function to mask every other thing other than our region of interest. So I will just define this function def region of interest, and this is going to take 2 parameters. First will be the image and second will be the vertices. So vertices, and inside this function, let me just minimize this terminal also so you can see the function. So inside this function, in the first step, we are going to define a blank matrix that matches the image height and the width. So this will be the easy step. We are going to define a variable called mask, and we are going to use np.zeros like method which is going to take one parameter, which will be our image matrix. Now in the next step, we are going to just retrieve the number of color channels from the image. This will be the easy step also. So channel count, and then we are going to just say image dot shape, and at the second index we are going to find out the channel, because we have seen that image dot shape is going to give you three values: height, width, and the channel count. So this channel count is coming from this index. Now in the next step, what we are going to do is we are going to create a match color with the same color channel counts. So I'm going to just say match underscore mask underscore color. This will be our variable name, and then we are going to just take 255 comma and then multiply it by the channel count. So let's multiply it by the channel count. So this is going to create a match color with the same color channel counts. Now in the next step, we are going to fill inside the polygon using the fill poly method, because we have our region of interest and we want to mask every other thing other than our region of interest. So we are going to just say cv2 dot fill poly, which is going to take few arguments. First will be our mask, second will be the vertices, which we are providing using the second argument, and the third argument will be our match mask color variable. So we are going to pass this variable as the third argument, and in the next step we are going to just return the image only where the mask pixel matches. So I'm going to just say masked underscore image is equal to cv2 dot bitwise and. So we are going to just apply bitwise and using this bitwise and method, and the first argument here will be the image, and the second argument is the mask, which we got using this zeros like method, right? And in the last step we are going to just return this. So I'm going to just write return this masked image, and that's it. So we are going to just apply our region of interest on the image using this method, and then we are going to just get our image which contains region of interest, and any other thing will be masked. So now it's time to use this method. So we are going to just use this method using this variable. I'm going to just define a variable called let's say cropped image or masked image, whatever you want to write here. So let's say cropped underscore image, and then we are going to just use this function, which is a region of interest function, which takes this argument. So because we have already read our image in the image variable, we are going to pass this as the first argument, and the vertices is simply our region of interest variable. So this region of interest variable we are going to pass using numpy dot array method. And let's split this line so we will be able to see what I'm doing inside this np.array method. So first of all, the first argument will be our region of interest variable, which is this one, region of interest vertices. So in the square bracket we are going to just pass region of interest vertices, and the second argument here will be np.int32. So np.int32, and now we are going to just show this image using our Matplotlib window. So let's run this code and let's see what happens when it runs. And there is a problem here. So let's see what the problem is. So you can see this problem is coming from this line, and most probably this region of interest has some problem. So you can see we have passed this first element as the tuple, second element as the tuple, and the third element also we need to pass as a tuple, and that's why it's giving us the problem. So I have just fixed it, and let's see what happens when we run this code again. and you can see our image is now masked with our region of interest. So we have defined our region of interest from this point to this point to this point. So now we have only this region of interest, so we will be able to easily find out this lane line and this lane line inside our region of interest, and any other distraction will be masked now, right? So this is the first step which we have achieved, which is masking our image and just applying our region of interest on the image. In the next step, we are going to see how we can apply the edge detection and find out the lane lines on the image. So this we are going to see in the next video. So I will see you in the next video.